All right, guys, we're doing 11.3b surface area of cones. I can determine the surface area of cones. And this is actually one of the last things we're going to do with surface area here before we move on to volume, which again is talking about the space something occupies, the inside. But again, we're still talking about surface area here, and we're talking about cones. Yesterday, we talked about pyramids, which is really going to help us today when we talk about cones as well. So again, I just want to go over our basic definition of surface area. Surface area, just going to abbreviate that as SA, equals lateral area, which I'll abbreviate as LA, plus the bases, or base if it just has a base. And you notice this is very similar to that of the pyramid, in that we don't only have one base here. That kind of comes up to a point, so we don't really have multiple bases here. So it is correct just to say base here. So I want to start actually at the same place we've always been starting. We've kind of been looking at the base first to try to identify what we have, and the pure fact that this is a cone because its base is a circle. Okay, so if I look at this, I have this area right here is my base. Okay, so if I'm trying to cover that particular surface, then we know already that to find the area of a circle, so we're going to work on our base first. The area of a circle is 1/2 pi r squared. Okay, so 1/2 pi r squared is going to give us, sorry, that does not need a 1/2. Where am I getting that from? I'm thinking about a triangle here. I keep trying to put that 1/2. Okay, area equals pi r squared, right? So to find the area of a circle, pi r squared. But now let's think about this lateral area here. So again, I want you to just think about what if I dissected this thing? If I made a cut right down the side of it right here, what would it actually look like? And you got to think about this really, and it really helps to have something to actually hold in your hand to be able to cut. But if you look at this and you think about this, really, I'm going to kind of end up with this shape. All right, I'm going to end up with a shape that really looks like this, which really looks like a triangle. Okay, so it looks like a triangle with one distinct difference. Okay, we have this rounded shape kind of here at the bottom. What I want you to think about is, what does that rounded shape really represent? Okay, when I unfold this lateral area of this, again, I'm not talking about the circle because it's already been done, but if I'm thinking about the lateral area of this, what is this particular portion right here? Well, ladies and gentlemen, this portion right here is actually the circle all the way around, right? It's the bottom of it's the circumference. So again, what is circumference? Circumference is 2 pi r, and we're using the formula that still has r in it because I already have r in my base that I'm talking about. So if I'm talking about my lateral area here, I know that I've got 2 pi r here as a part of my base. But again, I have this triangle here. But what is the height of this actual triangle? Because again, if I'm going to use triangle as part of my formula here, then I've got to think about, well, what is this actual height? Well, I want you to think about the fact that this height is actually this slant height right here. I'm going to use a different color. So it's really this slant height right here. Okay. And remember, we noted slant height as being the cursive letter L. So really, that's what this height really is. If I'm talking about the piece that I've kind of brung out of this, this is actually my slant height. So when I'm talking about the lateral area of a cone, then what I end up with is, again, think about the fact that this is half, right? This is made like a triangle. So typically, when I'm talking about the area of a triangle, it would be 1/2 the base times the height. Well, it just so happens that I have 1/2 here, but the base is 2 pi r, and my height is actually my lateral height. Okay, so let's think about how this works out here. It's actually a little bit of mathematics here to do this, but 1/2 of 2, 1/2 times 2 is actually 1. It just kind of goes away. So what I'm actually left with is pi times r times the slant height. Okay, so if I'm talking about the lateral area of a cone here, then actually what I have is pi times r times L. So let's just kind of sum up this formula here. So the surface area of a cone is actually my lateral area plus my base. So my lateral area is pi r L, or pi times the radius times the slant height, plus pi r squared. Okay, so it looks very familiar with the cylinder, the one that we had for a cylinder. But again, in this case, I don't have this extra base up here on top. Okay, so this would be the formula that you would need to use to find the surface area of a cone. So let's put some numbers on this particular one here that we're working with, and that'll make it make a little bit more sense. So let's say that this, in fact, is 4 centimeters. And let's say that my slant height here is 8 centimeters. Okay, so really all I have to do is just substitute everything into my formula. So I'm going to go down here to the bottom. Pi times r, which is 4, times my slant height, which is 8, plus pi times radius 4 squared. All right, and we can just kind of do the math here. 4 times 8 is 32 pi plus 16 pi. So for this particular problem that we're working on, we're going to end up with 48 pi centimeters squared. 48 pi centimeters squared would be our answer for that. And again, you're going to do exactly the same thing. The only thing I would caution you to look out for is, for example, let me just draw one out really quick. Let's say that you are given something like this, and you're told that this is 10 meters. Again, I want you to note here that they are giving you the diameter, okay? So in this case, you need to divide that in half, which means that your radius would actually be 5 meters, okay? 5 meter radius. So you would need to divide that in half before you start, and then put that into your formula. Obviously, you're going to need to have that slant height as well. They may actually give you the perpendicular height. For example, they said that this was 4 meters. You may have to do Pythagorean theorem in order to figure out what this L is, okay? So a little bit of work here, but again, it's very similar to what you did with pyramids, and hopefully this will be an easier task for you to be able to do. As a matter of fact, you only have, looks like, about 8 questions. So should be able to do this pretty easily, pretty handily. If you do have trouble, I want you to make sure that you reach out to either me or Miss Wheeler, and we'd be glad to help you work through some of these issues. Thanks.